So we have parabola question again. Let's see. PQ be the focal chord of this parabola. As soon as you see a parabola, you start drawing a parabola. Okay, and recording everything what is given to you. Okay, so this is your parabola. Okay, y square is 4ax. Then PQ is a focal chord. Okay, so let's draw PQ as a focal chord. What does focal chord means? That it passes through the focus, right? Okay. Now, tangents at P and Q meet at a point. So let's start drawing tangents at P and Q. Okay, so let's say this is tangent at P, and let's draw tangent at Q. Okay, they are meeting at a point. Let's call it T. Hmm. And this T is lying on this line where A is positive. Okay. Now, if the chord PQ subtends an angle theta at the vertex, okay, so what is my angle theta? So if I draw this and this, okay, this is the angle theta at the vertex, then tan theta equals to what? That's what they are asking. Hmm. Let's get all the concepts correct, okay, first. So let's assume, okay, parametric coordinate for P, let's say T1, and Q, let's say T2, okay. What do we know about that? What does it mean? That T1 I assume, that means I can assume coordinate of P to be a T1 square comma 2a T1. Correct? Okay. Now if PQ is the focal chord, what do you know about that? That T1 T2 is negative 1. Right? That's what you know. What else do you know? If I'm drawing tangents at the end points of a focal chord, okay, so first of all, any chord, where does it meet? Okay, if I draw a tangent at endpoints of any chord, then they meet at the point whose coordinate should be a t1 t2 a t1 plus t2, correct? But now this is a focal chord, right? Then we already know that t1 t2 is how much? Negative 1 minus a. I don't know about that, okay, but I can figure out, right? Because this is the intersection point is lying on what? This line. Yes. Okay, so what do? We just plug in. Now we know the x coordinate, right? So we plug in the x coordinate, okay? So minus 2a, right? Instead of x, I'm plugging minus a plus a. So what do I get? Y to be minus a, correct? Okay, so what do I get? That the coordinate of the intersection point is negative a and negative a. Okay, so that's a coordinate. Do you know anything else? Yeah, just now you saw, right? See, x coordinate is negative a, that they are meeting at the directrix. Yes, so this is the line, right? X is minus a, so they meet at the directrix. And one more property, just recall that, subtend 90-degree angle over here. hmm? I will check, okay, all these properties we know, check, check, check. Okay, so that 90-degree thing is also checked. Okay, now let's start doing our question. Okay, so I already got all the points. So let's assume coordinate for P. Let's say T1 is T, let's say, okay. So I can assume AT square and 2AT. Then what can I assume for coordinate for Q? Because T2 would be then minus 1 upon T1, that is T. So T2 is minus 1 over T, okay. So I can write A over T square and minus 2A over T. That's the coordinate for Q, okay. Now what do we have now? We need to know what is the this angle. Okay, how do I know angle between any two lines? Okay, suppose the slope of, let's call this O origin. Okay, let's say I know slope of OP. Okay, OP, that's m1. Okay, let's say I know slope of OQ, that's m2. Okay, then the acute angle between them, how do you get that? Acute angle, let's call it alpha. Okay, because theta is the obtuse, you know. Why do I think that theta is obtuse angle? Just now you said, right, that here they're forming 90-degree angle. If you move more, like if this point you can move further, then it would be lesser, right? Okay, if you move that point closer, then it would be more. You understand that this is 90, right? O is closer to the chord, right? So it will be more than 90, so obtuse angle. Okay, got it. Okay, so now I'm trying to get acute angle between them. Okay, I will do pi minus that. Okay, I'm getting this angle. I will do pi minus that alpha to get that theta. just just see, okay, if you understand. Okay, comment me if you don't. So m1 minus m2 upon 1 plus m1 m2. Okay, that's how you write that. Okay, now m1, can you give me m1? What's the slope of OP? Y2 minus y1. Okay, so sorry, y2 is 280, y2 minus y1 upon x2 minus x1. Okay, 2 tt gets cancelled, so 2 upon t, that's the slope of OP. Slope of OQ is what? Same. Y2 minus y1 upon x2 minus x1. 2 cancel, t gets cancelled. So minus 2t. Okay, let's start plugging in the values. M1 is 2 upon t, minus of minus 2t upon 1 plus 2 upon t and minus 2t. Okay, what do you get? 2 is out. Okay, you get t plus 1 by t. And here what do you get? You get 1 minus 4. Okay, so what are you left with? 2 upon 3. Okay, in the modulus inside you have minus t plus 1 over t. Do I know this? T plus 1 by t. Can I know that? Okay, look at here. Okay, t, compare the two, this and this. Okay, I'm writing here. What do you get? You have got a t1 is my t here and t2 is minus 1 by t here, right? That is equal to minus a. Okay, a gets cancelled. So you have t minus 1 by t is minus 1. Can you get t plus 1 by t then? Yeah, is it simple? T plus 1 by t, okay, whole square is equal to t minus 1 by t whole square plus 4 t times 1 by t. Okay, a plus b whole square, right? That formula, a minus b whole square plus 4ab. Okay, what do you get? Minus 1 whole square plus 4, that's 5. Okay, so t plus 1 by t will be square root of 5. Okay, so let's plug in here. This is square root of 5. So the modulus value would be this upon 3. But then this is the acute angle. Okay, what is the obtuse angle? I want tan theta. Okay, tan theta is what? Pi minus alpha, that is minus tan alpha. Okay, so I am going to see this I got. Okay, this is the acute angle. Theta is the obtuse angle, so I have to do pi by 2 minus alpha to get my theta. Okay, this is my theta. Okay, so minus tan alpha. Okay, so I am just going to report minus 2 root 5 over 3, and that's my option D. Okay, so actually in this question you need to know so many properties, right? Okay, so I will see with another question.